Good day, student of excellence. How are you doing? Oh, God bless you.
Fine, thank you, sir.
Mr. Apollo, good afternoon.
Good afternoon. How are you? Good girl.
Fine. Sir, I just sent my assignment now, no.
Yes, I saw it. You did a very nice job. God bless you.
Yay!
Yes, after this class, I will mark and send the feedback.
Yay!
Yes.
Sir, even me too, I did good.
Yes, I saw it. You did a very nice job. God bless
Thank
you.
you, sir.
Yeah.
Amen,
Good afternoon. How are you?
Good afternoon, sir.
All right. We are into chemistry of non-metals. Last time we discussed hydrogen, and today we are going to talk about oxygen as a non-metal. But before we start, let us pray. Then we briefly revise what we did last week before we start the business of today. So can somebody pray for us?
In Jesus' name,
Amen.
King of Kings, Lord of Lords, we thank you for today. We thank you for allowing us to see this wonderful day. It's not because we are beautiful that you made us see this. Father, we give all the praise, all the honor, all the adoration. Father, Lord, as we attend this class, Father, Lord, may you give us wisdom, knowledge, understanding, like that of Daniel in the mighty name of Jesus.
Amen.
We shall come out in flying colors in Jesus' mighty name.
Amen.
Peace be with you.
Amen.
Amen. All right. I welcome all of you to this class once again. Like I said, in our last meeting, we discussed the properties and uses of hydrogen as a non-metal. Today, we are going to discuss oxygen as a non-metal. But let me ask us briefly about what we did on hydrogen last week. Who can remind us of at least 2 chemical properties of hydrogen that we discussed in the last meeting? 2 properties of hydrogen. Busayo, can you remind us 2 properties of hydrogen? Busayo, can you hear me?
Yes, sir.
Yes. Mention 2 properties of hydrogen that you know. 2 properties of hydrogen.
I was in the last class.
Pardon? I can't hear you well.
I was not in the last class.
What happened that you did not attend? Edward Mundy, give us only 2 properties of hydrogen, chemical properties. Kezia, please unmute yourself, all of you, so that we can briefly revise what we did on hydrogen last time. Abba, praise. Praise Abba.
Sir?
Tell us 2 chemical properties of hydrogen that we discussed last time.
I was in the last class.
What happened that you did not attend the last class, please?
There was no light. I couldn't charge.
Boy, Fasewe, I like your hairstyle. Can you please tell us 2 chemical properties of hydrogen?
Sir.
Yes.
Metallic hydride.
It does what?
Metallic hydride.
Correct. Formation of metallic hydride. Hydrogen reacts with metal. Example, the highly reactive metals in group 1 to form metallic hydride. Yes, another one.
Sir.
Yes.
Hydrogen.
Formation of non-metallic hydride. Example, hydrogen fluoride. Then
Hydrogen chloride and
Molten.
Right.
Yes.
Hydrogen fluoride. Yes, yes.
That
yes,
is
yes.
very good.
Hydrogen.
Isaac Newton, can you give us 2 physical properties of hydrogen that you know? Isaac, please. Ibn Abu Waste. Give us 2 uses of hydrogen. 2 uses of hydrogen waste. This chart, please, can you tell us 2 physical properties of hydrogen? Eh?
So I was not in the last class.
Freezing point and melting point.
Oh, okay.
That's all you see.
We are listening.
It is colorless, odorless, and tasteless gas. It has very low points at 253. I'm not reading it.
That is good.
Boiling
She's not reading it. She's a good girl, I know. She knows what she's telling us. Ene, please unmute yourself. I'm asking you a question. Can you briefly describe the reducing action of hydrogen as one of its chemical properties?
Yes, sir.
Okay. Hydrogen is a reducing agent. Can you briefly discuss the reducing action of hydrogen?
Okay, sir.
We are listening.
Hydrogen as a strong reducing agent
Yes.
is always passed over the heated oxide.
Correct.
Hydrogen
So
as
give
a
us what?
reducing agent.
All right, let me complete it for us. The reducing action of hydrogen is that hydrogen extracts oxygen from lead-2 oxide. Lead-2 oxide plus hydrogen gas balance to lead solid plus steam, which is water. What hydrogen does there is that it extracts oxygen from the compound lead-2 oxide. And another chemical properties of hydrogen is what Busayo told us. So let's move on to uses. One of the uses of hydrogen is that hydrogen is used for the synthesis. Please minimize that background noise, please. That background noise, please minimize it. All right, I said that hydrogen is used for synthesis of ammonia in industry through a herbal process for the large manufacture of ammonia, which is a heavy chemical. Then hydrogen is used for the manufacture of soap, margarine through hydrogenation process. Hydrogen is used, e.g., a liquid hydrogen is used as a fuel for rockets. You can simply put it, a liquid hydrogen is used as a fuel rocket or as a rocket fuel. Another usage is that hydrogen is used for the manufacture of oxyacetylene flame or hydrogen flame. You can call it oxyhydrogen flame. Oxyhydrogen flame is used in industry for cutting and welding metal because it produces a very large amount of heat that is strong enough to cut metal and weld metal together. These are some of the uses of hydrogen that we discussed. We also said that hydrogen is used for filling balloon. Can you hear me, please? Daniel?
Yes, sir.
Okay. Can you just mention 3 out of the one I mentioned right now?
Hydrogen is good as rocket fuel.
Kezia? I said hydrogen is used for filling balloon. Liquid hydrogen is used as a rocket fuel. Hydrogen is used for the manufacturing of oxide hydrogen flame, which is used for cutting and welding metals. Hydrogen is used for the production of soap, for the production of margarine through hydrogenation process. Hydrogen is also used for the synthesis of ammonia. Hydrogen is also used for the synthesis of hydrogen chloride acid. These are what we discussed, among others. So today we are going to talk about the chemistries of oxygen. So thank you so much for the brief revision. Let me share my screen. Let me share my slide with you so that we can start the business of today. Now the topic on board is oxygen. Let us look at the contents, the subtopic that we are going to treat. Number 1, introduction, electronic configuration and bonding capacity of oxygen. Number 2, laboratory and industrial preparation of oxygen. These are the 2 subtopics that we are going to discuss. Introduction, electronic configuration and bonding capacity of oxygen. Number 2, laboratory and industrial preparation of oxygen. Then in the next class, we will talk about physical and chemical properties of oxygen, compounds of oxygen, and then uses of oxygen. Please, for the last warning, students, for the last warning, I told you, please, try as much as possible to avoid any form of underground noise. Do you hear me, students?
Yes, sir.
All right. If I catch you making noise in any form, either from the background in your environment there, or your own system, or you yourself is talking irrelevantly, in fact, I will remove you from the class today. Now, let's talk about the subtopic number 1, which is introduction, electronic configuration, and the occurrence of oxygen. Now, what is oxygen? Oxygen is an element that even a layman knows. It is a popular substance known on Earth, but chemists are interested in knowing much about the chemical reactivities, properties, and uses of oxygen. Then we have the chemistry of oxygen in detail. Then what is an oxygen? Oxygen is the first element in group 6 of the periodic table. It is a diatomic molecule and the most abundant element on Earth. Who can tell us at least 3 elements in group 6 of the periodic table apart from oxygen? Who can mention 3 elements in group 6 apart from oxygen?
Fluorine.
Yes?
Sulfur.
Come again, please.
Sulfur.
That is good, sulfur. Yes, another element in group 6 apart from oxygen.
Sir,
is the only sulfur that you know?
Sir, selenium.
What?
Selenium.
Beryllium or what?
Neon.
Selenium.
Are you a chemistry student at all? You are just joining the class.
Sir,
Helium is in group 8.
Selenium.
If you are talking about
Chromium.
the element in group 6 in the periodic table, oxygen is the leading
Chromium.
element, followed by sulfur. Then
Chromium.
after sulfur is what?
Selenium.
Selenium. God bless you. I thought you are talking
Polonium.
about helium. Helium is in group 8. It's a noble gas.
Polonium.
Yes. God bless you. Now, what do we mean by the statement oxygen is a diatomic molecule?
Sir,
Yes.
in its outermost shell, it has only one electron here.
It has how many electrons in the outermost shell?
One, sir.
One.
Only one. It means you are telling us that oxygen is in group 1 in the periodic table. Chemistry
No,
students.
sir, in the outermost shell it has 7.
In the outermost shell, oxygen has 7 electrons. It means it's in group 7.
Yes, sir.
It has 6 electrons.
In its outermost shell, oxygen has 6 electrons.
6 electrons.
It is in group 6. Remember, the classification of all elements in their respective groups in the periodic table is based on the numbers of the electrons in their outermost orbital. So, if any element is in group 6, it means that element has only 6 electrons in each outermost. Are you clear with that?
Yes, sir.
Okay, please don't make that kind of mistake next time. How can you tell me that hydrogen has 1 electron in each outermost shell? Oxygen has 7 electrons in each outermost shell? No. It has 6 electrons in each outermost shell. That is why it belongs to group 6 element in the periodic table. So thank you. God
Sir,
bless
why
you.
did you not talk about diatomic?
Now, oxygen occurs in nature in both free and combined states. Why? We say that oxygen occurs in nature in both free and combined states. But look at the percentage occurrence in free state. It is just 21% by volume of atmospheric air. While in combined states, it accounts for about 55% by the mass of the earth crust. Do you understand? Meaning oxygen in a way is highly reactive. That is why it does not exist freely like that. Now I said oxygen is a diatomic molecule. This statement means oxygen does not exist all alone as a single atom. It exists in form of O2. That is diatomic. It means 2 atoms of oxygen combine together to give you a molecule. 1 molecule of oxygen. That is how it exists. Then we refer to that as a diatomic molecule because it is highly reactive. It does not exist alone. Do you understand? The existence is a covalent in nature. 1 atom covalently bonded to another atom to give you a molecule of oxygen. That is how it exists, free in nature. Do you understand? In atmosphere. Now, we are saying that in the combined form of it, it accounts for about 55% by the mass of earth crust. It also exists in ocean and in the air. Oxygen is present in trioxosilicate form, trioxocarbonate form, and the oxides of both metals and non-metals, which make up the rocks and clays. Water that we know, water that is H2O, has about 88% of the oxygen by mass. The water you drink, the water you use for domestic activities, water that is life, you know. Even in your body, I can tell you that 70% of your weight in your body is made up of water. Water everywhere around us and even in us. Water, one of the most abundant element or compounds on earth is made up of 88% of oxygen by mass. These are the occurrences where and where you can find oxygen. Now, let us summarize this. We can have oxygen free in air, in atmospheric air, at about 21% by volume of every air that you can have. Then in combined form, we have it in ocean, we have it in trioxosilicates, we have it in trioxocarbonates, we have it combined as an oxide of metals, and as well in the water, that is the most common abundant compound on earth. All right. This is the brief introduction I have for you in oxygen. Now, talking about the bonding capacities of oxygen. What do we mean by this bonding capacity of oxygen? That is the ability, the potential to which oxygen can get bonded to another element or another oxygen atom to form a molecule is the bonding capacities of oxygen. Now I said oxygen is an element in group 6A of the periodic table. Each atomic number is 8 with 6 valence electrons and has an electronic configuration of 1s2, electronic configuration of 1s2, 2s2, then 2p4. Let us count together. I hope you know the rule. 1s2, 2s2, and 2p4. 2 plus 2 plus 4 gives us 8. This is the electronic configuration of the oxygen atom. Now, oxygen forms a complete octet by either accepting 2 electrons from a donor to form oxygen ion, or to form oxide ion. Forgive me, it's not oxygen ion again, it's oxide ion in this case. That is O2 raised to power minus 2. We call it oxide ion. And what are we saying? We are saying that oxygen forms a complete octet by either accepting 2 electrons from a donor to form oxide ion in an ionic substance, e.g., we have quicklime, which is calcium oxide, magnesium oxide. These are very good examples of ionic substances. Now, this can be done by either accepting or sharing. By the time oxygen accepts electrons from a metal, example, sodium, another example, magnesium, another example, zinc, it forms the ionic oxide of the respective metals mentioned. And by the time it involves sharing, it forms oxide. For example, we have carbon 2 oxide, we have carbon 4 oxide, like that. That is, the sharing is covalently bonded together. And whether oxygen is accepting electrons from the donor, e.g. from metals, or oxygen is sharing electrons with another oxygen atom or atom of another non-metals, e.g. carbon. it is all about trying to attain the octet configuration. Do you understand? To attain the electronic structure of group 8 elements so that it will become stable. That is the essence of being reacting with either another compounds of non-metals or a compounds of metal. Let me repeat this.
Sir.
Yes?
So if a substance or an element gives out
Repeat.
electron,
Yes, I didn't hear you well.
So I said if an element gives out electrons, is it negatively charged?
Yes?
No, it's positive.
Okay, thank you for the answer. Now what I'm saying is that oxygen has 6 electrons altogether, and it has 6 valence electrons in each outermost shell. This oxygen can attain the octet configuration by accepting electrons from donor or by sharing electrons with atoms of non-metals or with atoms of another oxygen atom.
No.
Do you understand? Isaac Newton. What I'm saying is, oxygen can attain the octet configuration by either accepting electrons from donor or sharing electrons with another non-metals or with other oxygen atoms to form a covalent compound. E.g., we have oxygen plus oxygen covalently bonded to give you oxygen molecule. Oxygen plus carbon covalently bonded to give you carbon 2 oxide, carbon 4 oxide. Do you understand? And in this case, it appears to attain the octet configuration to have electronic structure of group 8 elements. That is what I'm talking about. Ene Ochai, Ibnabo West, Dinga Magic, Martin, Letitia, Daniel, Solomon, Alex Garuba, I know you to be a stubborn student. I will remove you. Put on your video. Put on your video, Alex. Otherwise, I will remove you from my class.
Sir.
Yes?
I cannot see your slide.
Because of what?
Sir, I don't know.
Ochapa, do you understand what I've just explained?
Yes.
You understand very well. Put on your video. I can ask you question and you too can ask me question.
Shall I explain again?
Neoma, you should not allow me repeating myself always. All right. Let me share my slide with you so that we proceed. We are talking about the bonding capacities of oxygen. Now, oxygen form a complete octet by either accepting 2 electrons from a donor to form ionic oxide or substance, or by sharing 2 electrons with other atoms to form a covalent substance. At room temperature and pressure, oxygen exists as a discrete gaseous diatomic molecule. The atomic molecule is O subscript 2.
So we can't hear you.
All right. we are saying that at room temperature and pressure, oxygen exists as a discrete gaseous diatomic molecule.
Sit your head now, huh?
And the two atoms are joined together by double covalent bond. The two atoms, there is A here, are joined together by two covalent bonds. See the two covalent bonds here? That is O double bond O. O double bond O gives you the double covalent bond. Look at it down here. Now let me take you to the laboratory and industrial preparation of oxygen. How do we prepare oxygen in the laboratory? In the first place, let's talk about the laboratory preparation. Laboratory preparation of oxygen. Number one, we can prepare oxygen in the laboratory by thermal decomposition of salt containing anions very rich in oxygen, e.g. potassium trioxochlorate 5. Now, there are two general and common methods for the laboratory preparation of oxygen. Number one, we prepare it from the decomposition of trioxochlorate 5 salt. It's a sort of potassium. Look at my equation for the reaction. 2 molecules of potassium trioxochlorate 5 decomposed on heating under the influence of a catalyst, that is manganate 4 oxide catalyst. It breaks the compound into potassium chloride solid and the 3 molecules of oxygen gas. There is arrow here. There is arrow here between the reactant and the product. The reactant is 2 molecules of potassium trioxochlorate 5, while your product are the potassium chloride and 3 moles of oxygen gas. You are using this catalyst, manganese 4 oxide, to quicken the rate of reaction. Do you understand? I repeat, thermal decomposition of salts containing anions rich in oxygen, example, potassium trioxochlorate 5. The equation for the reaction is given below. Look at it. Isaac Newton, look at it. In fact, I was very impressed by the assignment you sent to me last time. You really sat down and arranged the assignment for me, and I gave you 5/5. Ibn Abu Waste, you did not submit your assignment. Let me talk to you about my assignment. Anna, you did not submit my assignment. Zichard, you did not submit my Miracle, you did not submit my assignment. Mr. Sommer, who is this Mr. Sommer? I will remove you if you did not write your correct name here. Who is Mr. Sommer?
An assignment too.
That is Adriel.
Who is this Sommer?
That is Adriel.
I will remove you. If you, I will remove you. What do you mean by Mr. Sommer? Is that not Garuba? Alex Garuba. Is that how you will change your name every minute? Alex
It's
Garuba.
not Alex Garuba.
It's not Alex.
Okay, Engineer Ejiro, don't worry, I will remove you. Ejiro, you have never submit a single assignment throughout our virtual teaching. Bola, you have stopped now, isn't it? Edward Monday, you did not submit. Isaac, I give you kudos. Perfect, 5/5. Then Mark, you did not do your assignment. Abba Praise, I don't know whether you are with us or not. Oziofu, I didn't see your last assignment. Ochapa, you did not submit my
I
assignment.
submitted though.
Okay. I will check.
Okay,
Karuba,
sir.
sorry, it's because of Ejiro that confused me.
Okay,
Precious,
sir.
Peter.
I check my own.
Pochon, my best friend, you did not submit your assignment. Ayuba, please,
Sir.
do your, see, if you think that we are not gathering all this record, by the time you come, your first year, your second year, these are the things that we are going to use. Me, I will use my own, even if other teachers did not use their own. I'm telling you, we can't just be wasting our time, energy, and every other resources like this.
Mr. Obolo,
We are
submit
joking.
an assignment too.
Eneupa, you did not submit your assignment.
Sir, I submitted. Sir, this is Joy Upa. I submitted.
Wait, I cannot even see your brake lights.
Sir, I submitted my assignment.
Even
Sir,
if I
maybe
don't know
it's
your name.
network or something.
That is good. Abba praise, you are not my friend
Samia, I
again.
submitted. I can even send you the screenshots.
All right. I've explained the laboratory preparation of oxygen. Number one, thermal decomposition of salt containing anions rich in oxygen. Example, potassium trioxochlorate 5 decomposed on heating under the influence of manganese 4 oxide as a catalyst to give us potassium chloride and oxygen gas.
Mr. Obolo.
Yes.
Mr. Obolo.
Yes.
Sir, please, can you send either the email or your WhatsApp phone number so that I can send the assignment? The email sometimes does not go for me.
Oh, okay.
Yes,
I will
sir.
send it. You are a good girl.
Thank you, sir.
All right. Now, laboratory and industrial preparation of oxygen. Number one, we discuss it. So look at the diagram. Look at my diagram.
Sir, should we draw it?
No, don't worry. I will send the notes.
Thank you, sir.
You're welcome. God bless you. We have potassium trioxochlorate 5 plus manganese 4 oxide. You can see it on the diagram. Then you have it inside the boiling tube. Then you heat it from below. Connected the system to the delivery tube, and the delivery tube is connected to the gas jar in a water bath. Now you collect your oxygen gas by the downward delivery, by the upward delivery and downward displacement of air. Look at my diagram very well, then I will explain. Can you see my diagram very well?
Yes, sir.
Okay.
Yes, sir.
This is an illustration for the laboratory preparation of oxygen from thermal decomposition of potassium trioxochlorate 5. You understand?
Yes, sir.
A laboratory preparation of oxygen from thermal decomposition of potassium trioxochlorate 5. Let me correct something here. Potassium trioxochlorate 5. Then you put a salt of the potassium trioxochlorate 5 inside, then you heat it from below. As you can see, then you get your oxygen by upward displacement. Sorry, upward delivery and downward displacement of air. Then you have your oxygen above the water air. That's water. Because it is not soluble in water 100%. It is slightly soluble in water, so we can collect it above water. We say oxygen is partially soluble in water. Right, God bless you. Let me go to the method 2 in the laboratory preparation. Decomposition of hydrogen peroxide is another method. In this case, what do we do? Remember, in the decomposition of potassium trioxochlorate 5, heat yes. In the decomposition of hydrogen peroxide, we don't need heat. No heat is applied to decompose this. The reason is because hydrogen peroxide does not need heat before it can decompose, but By the time you just expose it to sunlight, it decomposes easily. That is the reason why. Are you getting me?
Yes, sir.
Good. Immediately you expose it to air. You understand? Under the influence of manganese oxide, the moment manganese oxide touches it, then effervescence will occur, releasing the gas oxygen. The effervescence is a form of cracking sound that you will be hearing coming out from the test tube. If you add,
Sir,
yes,
sir, is it applicable to evaporation?
please, I can't hear you very well. Tell your
Sir, evaporation, is it the same thing that happens? Sir, in evaporation.
No, it's not evaporation. It's not the same thing. Okay. No, it's not the same thing. Look at what I'm saying. Are you with me now?
No volume.
Yes, sir.
Now, if you are using hydrogen peroxide to produce oxygen gas, the only thing you need is the catalyst, manganese oxide. You understand? You don't need
Yes,
heat.
sir.
A moment manganese oxide is in contact with hydrogen peroxide, effervescence will occur, which indicate the presence of oxygen gas. But for the thermal decomposition of triazochlorate 5, potassium triazochlorate 5, you need heat before it can decompose. But hydrogen peroxide decomposes easily without passing it through heat. Yes?
Okay, sir.
Are you clear now?
Yes, sir.
Okay, look at the equation for the reaction. 2 moles of hydrogen peroxide. Let me correct this equation. The name of the compound is,
I don't know, but it's not recording.
the name of the compound is hydrogen peroxide. So there is 2 here. Okay, see my 2 moles of hydrogen peroxide now in contact with manganese oxide, balanced to 2 molecules of water and 1 molecule of oxygen gas. This is the equation for this reaction now. Now, dry oxygen gas is obtained by passing it through a wash bottle containing concentrated tetraoxosulfuric acid. The gas is then collected by downward delivery and upward displacement of air. Since pure oxygen is slightly denser than air. We are together?
Yes, sir.
God bless you. Because of time, let me show you the diagram for the reaction. See my diagram here? Yes, my good student. Am I rushing you?
Sir, kind of.
Okay, time off.
No, sir, you are kind of rushing us.
Okay. I'll try to come down more than this for you. I have 20 volume of hydrogen peroxide. You pour into a tissue funnel. See my tissue funnel. When you pour 20 volume, that's 20 cm cube of hydrogen peroxide into the round bottom flask. Round bottom flask. You pour the 20 cm cube of hydrogen peroxide into it. Then you have the manganese oxide inside the round bottom flask already. When the hydrogen peroxide touches the manganese oxide, then it begins to decompose. Then the oxide, the oxygen now bubble out through the delivery tube. You can see the delivery tube connected to the water bath and the gas here, where you collect oxygen above water. Remember, because you are passing the air produced, that is oxygen, you are passing it through water, it is likely to be moist. And that is why you are using concentrated tetraoxosulfuric acid as a drying agent, so that you have it dry. Hello, students.
Hi.
Do you understand what I've just explained?
Yes, sir.
No.
Yes, sir.
Okay. Why do you pass the gas? Why do you pass the gas through concentrated tetraoxosulfuric acid? Why do you need to pass the gas? Oxygen gas. The oxygen you produced. Why do you need to pass it through the concentrated tetraoxosulfuric acid?
So that it will be dry.
So that it will be dried. Because you collected it over water, it is likely to be moist. And in order to dry it, you use
Sir, please go through his slides again.
a drying agent. God bless you. You are a good student. Now, let me check my time. Let me check. Yes. Okay, I have 10 more minutes. Just only 10 minutes.
Sir, please go through his slides again.
Send for me the email or your number.
Yes, I will send my email address to you and my WhatsApp number. Now, look at.
Okay.
I'm with you. Yes, somebody is talking.
Please go through the slides.
Let's look at industrial preparation. The two methods described are laboratory preparation. Then we have industrial preparation. For the industrial preparation, oxygen is produced in large quantity from the following. One, oxygen is obtained in by liquefaction. Full oxidation of the night air. The first is produced by water, vapor, and dust.
Hi.
Are you with me in this industrial preparation?
Yes, sir.
I have about 7 minutes to round up. So please get it fast. Then I will give you classwork and assignment and give you my email address.
WhatsApp number.
Okay. Who can mention one industrial preparation of oxygen for us?
Sir, from liquefied air.
How do we liquefy air?
Oxygen is obtained industrially from atmospheric air by liquefaction, followed by fractional distillation of the liquefied air.
Atmospheric air does what?
Is purified by the removal of carbon.
For oxide, Abi?
Yes, sir.
Water, vapor, and
dust.
What this means is that when talking about liquefaction of air, is to isolate the pure oxygen. Isolate it from the mixture. Remember, air is a mixture. True or false?
True.
Now, and the constituent of this air as a mixture, we have dust, we have water vapor, we have carbon dioxide, and we have oxygen. And it's oxygen that we need. Then by the time we remove all these other constituents, what we have is oxygen. Then we say we have liquefied air to get our oxygen. Do you understand?
Yes, sir.
God bless you. God bless you.
I
will go back. Just look at my slide now. The purified air is compressed at a pressure of about 200 atmospheres, heated and then cooled. By successive heating and cooling, the pure air becomes liquefied at about 20 degrees centigrade. This process is called liquefaction. The liquefied air is then fractionated by boiling. Nitrogen, being more volatile, boils first at minus 196 degrees centigrade, leaving oxygen behind, which is about 99.5% pure. And this separation technique is called fractional distillation. I will send you this note. I will press my coordinator so that he will send it quickly, please, because I know that the note is good for us. Are you with me?
Yes, sir.
You are always good student. I'm proud of you. Garba, sorry, I will not talk to you the way I talked to you from the beginning again. And please don't provoke me again.
Okay, sir.
Okay. Ejiro, don't provoke me again. All right. I've forgiven all of you.
I not provoke you before.
All right. Number 2, by electrolysis, Oxygen, like hydrogen, is obtained during the electrolysis of dilute tetraoxosulfuric acid. Dilute tetraoxosulfuric acid is otherwise called acidified water. Ghana. Mention 2 industrial methods of preparation of oxygen. This chart mention 2 laboratory preparation of oxygen. Now evaluation. Explain the following statement. Oxygen is a diatomic molecule. Number 2, write electronic configuration of oxygen. Number 3, mention 3 sources of oxygen. Then state the main process. That is number 4. State the main process involved in the industrial production of oxygen from air. These are my evaluation questions. Because of time, do we solve this and send them to me alongside the assignment? They are very easy. Yes, then my assignment, you can screenshot, and I will still send a note to you. I promise you I will fill it.
Okay, sir.
I just go through the notes now.
It's because that I'm rushing you like this. Sorry. Are we together, my good students?
That's your WhatsApp number.
Okay. 070.
Sir, go through the note, let's screenshot.
07065 969647. This is the first page. So that WhatsApp number 07065 969647.
Yeah, thanks.
Sorry, I will send a note to you so that we can read, and during the next class, I will revise that industrial preparation of oxygen because of time.
Yes, sir.
Oh, sorry for rushing. I don't want to rush you like that, but because of time, they are going to use this time for another subject. I can't use it.
Yes, sir.
Look at the evaluation again. Look at assignment. Thank you. God bless you.
Slow down.
Shalom.
Peace.
Thank you. God bless you. Isaac Newton. Precious.
Sir, we don't forget the assignment.
I like the way you arrange my assignment, and I know you are going to do this one the same way. So, we have come to the end of the class for today. God bless you, and stay safe till we meet in the next class. I love you all.
Thank you,
Sir, the assignment.
Excellent. Thank you.
Bye-bye.
Assignment.
Bye. Thank you. Father, we thank you for the success of this class. In Jesus' mighty name. Amen. Pamela, you did not talk. You are laughing.
For me.
All right. See you.